Hi friends, welcome to somethingcalledscience.com. Today we'll talk about the fascinating topic of monoatomic and polyatomic ions. So in this video we'll discuss two different types of ions, namely monoatomic and polyatomic ions. As you might know, ions are particles with a net electric charge. They can be either positively charged or negatively charged. If an ion is positively charged, we call it a cation. On the other hand, if an ion is negatively charged, we call it an anion. If you want to know more about anions and cations, we have another video about those topics. Now, ions can be classified into two main categories, monoatomic ions and polyatomic ions. As the names imply, the difference between the two is that monoatomic ions are made up of only one atom. Polyatomic ions, however, are made up of two or more atoms. These can be of the same or different elements. Both monoatomic and polyatomic ions have an electric charge, otherwise they wouldn't be ions. In the case of monoatomic ions, its net electric charge is simply determined by the number of electrons the ion has. If the ion has more protons than electrons, it has a net positive charge, and so it is a cation. On the other hand, if it has more electrons than protons, it has a net negative charge, and so it is an anion. Now, atoms can gain and lose electrons through forming so-called ionic bonds with other atoms. This means that one or more electrons are transferred from one atom to another. Let's look at a few examples of monoatomic ions. For example, sodium and calcium are both monoatomic cations. Common monoatomic anions include chloride and sulfide. So far the monoatomic ions. Now let's talk about polyatomic ions. Things get a bit more complicated with polyatomic ions because they are made up of multiple atoms. So how is the net electric charge determined in this case? Well, the overall charge of a polyatomic ion is determined by the balance of protons and electrons in the group of atoms that makes up the polyatomic ion. To better understand this, we need to understand how polyatomic ions form. Polyatomic ions form through so-called covalent bonds. Covalent bonds are chemical bonds in which atoms share electrons. Why do atoms share electrons? They do this to become more stable. Atoms tend to be more stable when they have a full outer electron shell. For most elements, this means having 8 electrons in their outer shell, although there are exceptions. By sharing electrons with other atoms, atoms can effectively fill their outer shells and achieve a stable electron configuration. And it is the sharing of electrons that is the process that leads to the creation of covalent bonds. An example is the sulfate ion, in which one sulfur atom is covalently bonded to 4 oxygen atoms. The shared electrons help stabilize the structure of the ion. What does this mean for the electric charge of the polyatomic ion? The overall charge of a polyatomic ion arises when the total number of electrons does not equal the total number of protons in the group of atoms. This can happen due to the addition or removal of electrons. For example, in the nitrate ion, the nitrogen atom is bonded to 3 oxygen atoms. The group has 1 extra electron compared to the total number of protons, resulting in a net charge of -1. Let's look at a few examples of common polyatomic ions and their formation. A first example is ammonium, which is formed from 1 nitrogen atom covalently bonded to 4 hydrogen atoms. The nitrogen atom has 1 extra proton compared to the total number of electrons, giving it a +1 charge. Another example is carbonate, which is composed of 1 carbon atom covalently bonded to 3 oxygen atoms. The group has 2 extra electrons compared to the total number of protons, resulting in a -2 charge. A final example is phosphate, which is formed from 1 phosphorus atom covalently bonded to 4 oxygen atoms. The phosphate ion has 3 extra electrons, leading to a -3 charge. So let's recap the differences between monoatomic and polyatomic ions. First, there are differences in composition. Monoatomic ions consist of a single atom. Polyatomic ions consist of 2 or more atoms. There are also differences in how their charges are determined. The charge of monoatomic ions is determined by the loss or gain of electrons by a single atom. The charge of polyatomic ions is determined by the collective charge of the group of atoms. And finally, there are differences in the way they are formed through bonding. Monoatomic ions are formed through ionic bonding, where electrons are transferred between atoms, typically between metals and nonmetals. Polyatomic ions are formed through covalent bonding, where atoms share electrons within the group and the entire group carries a charge. Summing up, understanding monoatomic and polyatomic ions is fundamental to the field of chemistry and as a consequence to the application of chemistry in various fields, including biology, environmental science, and materials science. Monoatomic ions with their simple structure and polyatomic ions with their complex arrangements both play significant roles in chemistry, and understanding their differences is important in chemical reactions and biological systems. Whether it's the formation of common table salt or the intricate processes that sustain life, ions are at the heart of it all. If you found this video helpful, don't forget to like, subscribe and hit the notification bell for more science content. It really helps the channel out. Let us know in the comments if you have any questions or topics you'd like us to cover next. Thanks for watching and see you in the next video.